Oladokun. So without further ado, I would like to welcome our chairperson to give his opening remark. Our chairperson is Engineer Bola Olowe FNSE, the past chairman, NSC Ibadan branch. Please, is he?
All right. Thank you, Doctor.
Thank you, sir.
I hope you can all hear me. Sorry, my video is playing up. I don't know why.
Oh.
But I'll just try and see how that can work. But I want to first of all thank the Department of Industrial Engineering for inviting me to this. Just a minute, please. For inviting me to the chairman of today's lecture, which I consider a great honor for being invited. And I also want to commend the Department of Industrial Engineering for instituting the lecture series and for keeping it going this past 4 years, you say? 4 years. So the lecture series has indeed brought the town to meet with the gown in a productive collaboration. And so it is indeed a laudable development, which I believe will provide graduates with the needed insights into what goes on beyond the classroom in the world of work. The world of work is a different ball game to the experience when you are within the four walls of the university. And so this series helps to somewhat give us some input, especially to this topic, will give us some hints about how to transit from classroom to the control room. I remember in my days in the University of Lagos in the early 80s, our lecturer then, Professor Ayodele Awujobi of blessed memory, used to tell us that what the university is doing is to teach us about engineering and not to make us engineers. He actually said that we will know how to become engineers when we get out of the university into the field, into the world. And on a personal note, I recall that in the University of Lagos, we were taught about dams. We were taught fluid processes, flow sluices. We were taught weirs, we were taught spillways. And we actually did some calculations, some modeling or whatever you want to call it. But at that time, these were hard to imagine and understand because we have never seen a dam before on all those things. We only see these things on the pages of our textbooks. It was only after I left the university and started working in a consulting firm where the design of dams, weirs, and spillways were being carried out that I had a good understanding and I was able to relate to what we were taught in the university. Then I just passed through the Ashijire, Ashijire Dam. I just passed through it and before then I just look at it in a passing glance until I got out and I now realized that actually Ashijire is a dam, is a gated dam. That has some rock fill and all that. And eventually I was able to also visit the place with my colleagues. So a lot of the things we were taught in the classroom may not have meaning to us until we get out and we are actually in the field practicing. So therefore, beyond the university, when we get into the world of work, we will meet a different scenario, which in some cases, students might not have been prepared for. The walls of the university is clustered, and so we seems to be protected from the outside world. So we have all these highfalutin ideas about things when we get to the world of work. So again, I want to thank the departments and especially the university for making the opportunity available to students so as to prepare them for the world of work. In this wise, I commend also the universities that have added courses in entrepreneurship into their curriculum. It is a sure way to prepare students for the challenges of life. You see, university education is to broaden the mind and help provide the knowledge and ability for the multidimensional world. It is no more business as usual, and you see your certificate as a meal ticket. Rather, it is a way to impact the world and bring something as it were to the table. So in these days, we see medical doctors who became photographers, and they are doing very well at it. We see architects who are musicians, and they are doing excellently well. So this topic is quite apt today to open the eyes of our students and to broaden their mind to see that they need to have a paradigm shift. They need to think out of the box when they get to the world. So therefore, once again, I thank the department for organizing this lecture with this topic. I assure all attendees that the time that we spend here is a well-invested time and will be beneficial to us. Thank you.
Thank you very much, sir. That was very insightful. There are some things that you will not understand until you actually see them outside of the classroom. So we should not put pressure on the classroom to do everything for us. But the classroom definitely prepares us to handle what we see outside the control room. For some people, the control room is an actual engineering control room. For some people, the control room might be a bank, it might be a hospital, it might be every other place that we have found ourselves as industrial and production engineers. Thank you very much, sir. So right now, I would like to welcome Professor O.A. Fakolujo to give his goodwill message. He's the Vice Chancellor, Joseph Ayo Babalola University, Ikeji, Arakeji. Yeah. Sir, the floor is yours. Okay, is he in, please? Let me see. I'm not quite sure he's here yet. Okay, we will move on to the next. Yeah, okay, he's not in yet. Yeah, we'll move on to the next person, which is our guest of honor. Like I mentioned, she was the first in here. No Nigerian time or African time or anything like that. She has been here right before everybody else, and she's Mrs. Adejoke Akinpelu. She's the Deputy Registrar, Directorate of Public Communication in University of Ibadan. So please let's welcome her as she gives her address.
Good evening, my dear participants. It gives me a lot of pleasure to be here with you this evening. I have a lot of interest in the Department of Industrial and Production Engineering. It is one of the departments in the university for which I'm being paid to publicize the activities and let the world know what is being done in that department. And I also have the singular honor of being a mother as well as a grandmother of the department. My son is in the 700 class, and my grandson just entered. He's now in the 100 level. So that every time I see Professor Oladokun, I tell him that I'm a part and parcel of your department to my prof, because my son is there and my grandson is there. So I wish the department a lot of success. And I pray that God will continue to strengthen Professor Oladokun and the others to make the department stronger than ever. I wish we all have a very nice evening. Thank you for inviting me. I'm most pleased to be here with you this evening. Thank you.
Thank you very much, ma'am. Let's give a round of applause. Like we all know, our department is a family department. So I'm not too surprised to hear that there is somebody in 700 and there's somebody else in first year, because that's how we do it. We are a family in IPE. It's all love where we are. Thank you so much for your address, mom and grandmom of of our department. So right now, we are getting ready to hear from our guest speaker, but I will not be doing the introductions. I am going to welcome engineer, is he engineer? Samuel Okun-Omo to read the citation of our guest speaker. So Mr. Samuel, are you ready and able to do it?
Yeah, I'm ready. I'm able.
Okay, does somebody need to mute themselves?
I'm home.
Okay, over to you.
So just give me a minute. I want to.
Oh, I
My name
think you
is. Can you hear me now? Hello. Hello.
Yeah, I can hear you, but there was an echo before. I think it's gone now.
Yeah.
Okay.
I was also connected to my. First, my name is Samuel. I'm a year 2 master student. I want to, before I read the citation, I just want to thank the department and the alumni for giving me the opportunity to speak here today. I am grateful, and I also want to speak on behalf of my of the year 2 master students that we see the contributions and investments you've made in us, and we really appreciate it, and we are really grateful. And I think that's just what we are grateful and we are thankful, and want to encourage. And this also inspires us to also do more for the department and also give back to the department when we enter into the workplace. So I want to thank you very much. So right now I'll share my screen. Screen. All right, can you see my screen now?
Yeah, okay. We can see now.
Yeah. So okay. So I'll start. Engineer Afolabi Oshu is a multidisciplinary engineering and energy professional with a strong blend of academic achievement and industrial experience, spanning mechanical engineering, industrial and production engineering, and energy operations. He holds a higher national diploma in mechanical engineering from the Polytechnic Ibadan, a Bachelor of Science degree in industrial and production engineering from the University of Ibadan and a Master's of Science degree in Mechanical Engineering from the University of Lagos. Engineer Afolabi currently serves as a process operator in a liquefied natural gas production facility, where he's actively involved in gas processing operations, LNG storage and loading, power generation, nitrogen production, water and effluent treatment systems, process safety management, emergency response, production monitoring, troubleshooting, and operational optimization. Now, with extensive experience operating and monitoring complex process systems, he has developed expertise in process control, plant reliability, operational excellence, risk management, and continuous improvement. His work focuses on ensuring safe, reliable, and efficient plant performance while driving sustainable operational outcomes. His professional interests include process optimization, operational excellence, process safety, reliability engineering, energy sustainability, industrial performance improvement, digital transformation, and leadership development, and work capability enhancement. Passionate about bridging the gap between academia and industry, Engineer Afolabi is committed to mentoring the next generation of engineers and promoting a culture of safety, innovation, continuous learning, and excellence in the sector. All right, so to further ado, I think we should welcome Engineer Afolabi Osho to speak. Thank you very much.
Thank you, Samuel. All right. Okay, daughter.
Yeah, the floor is yours.
All right. Okay. Good evening, everyone. I'm so delighted and honored to be with everyone tonight. And we like to start my special appreciation to the special guest of honor. That is in person of Professor O.A. Fakulujo, who is the Vice Chancellor of Joseph Ayo Babalola University. And I'm also tender my special thanks to Mrs. Adejoke Adejoke O Akinpelu. So why we were waiting for the meeting, so I can hear her discussion and interaction with Dr. So with the interaction, I can see that this is more that coming into our midst and the way she expressed herself freely. And special thanks to Engineer Bola Olowe. I've been seeing your face a little bit frequent in our meeting. Thank you very much, sir. And special thanks to Prof. Oladokun. So this evening, please allow me to quickly share my screen. Share settings. Okay, please, once you can see my screen, just let me know if you can see my screen.
Yep, can see.
Oh, all right. Okay, am I in slideshow view?
Yes, sir, you are.
All right, good. Okay, so tonight I will be discussing on the topic that says from classroom to control room, achieving process optimization and operational excellence in energy sector. So once again, my name is Afolabi Osho. So when Prof called on me that, oh, Afolabi, you are the one that will be giving this speech, I was, hey, Prof, oh, I'm just building experience. So Prof said, okay, no problem, you can do it. After all, with that short period of while that you've been around, so you should have gained some experience, and I've seen the good work that you are doing in the background. So thank you once again, Prof, for believing in me to come around to deliver this lecture for tonight. It's indeed a great honor. So the citation have been taken, so I'll just go straight to the introductory part. So tonight, why am I discussing this topic? So when it comes to energy industry, if we have a lot of people with technical skills, we have a lot of professionals, but in the real sense, what the industry is looking out for is the technical competence, the data-driven decision making, safety culture, and operational discipline, coupled with continuous improvement and digital transformation. So the organization that we are working with across globe, or even within different capacity as we may have it in different country. So they are not really competing about the volume, because by virtue of natural resources, we have some country that have this abundance of the natural resources more than the other. So the game when it comes to volume is not really the focus, but rather we are focusing on efficiency, reliability, and operational excellence. How best can we achieve with these limited resources that we've had in our capacity? So my focus tonight is not to deliver another lecture of optimization or operational excellence, but I'm here to share my transformation story of how a student of industrial and production engineering became an LNG professional operating in one of the complex industry in the world. Sorry, let me. Okay, good. Okay, is the next slide showing? So the first on my agenda is the gap between the classroom and the industry. So in the classroom, we were taught the various topics, various courses. I remember then we were taught thermodynamics, fluid mechanics, reliability, process control, statistics, the list going on and on. And if you look at the coursework, the cost, the number of courses that we took, they are really very lengthy. Some are coming twice, some even 3 times, just to make sure that we understand the rudiments, the fundamentals of what we need to get us equipped for the future. But the industry is actually looking out for different things. The industry is looking out for competency. The industry is looking out for problem solving. The industry is looking out for decision making. The industry expects us uh, how how can we identify risk and how can we effectively manage it. The industry is looking out for teamwork. How can we work together with our partners? Because yes, we've said that we've learned, we've said that we graduate with first class 2-1, all sort of things that we've said that that we have learned in the past, but you have it, other person have it. So how can we now work together as a team to make sure that the company goal is being achieved? So the industry is also looking out for proper communication, operational discipline, and soft skills. So all of this is what I will be touching gradually as we progress in today's lecture. So I've already explained in the previous slide that what we were taught. So it's not like what the school have taught us is not applicable. In fact, they are the fundamental, they are the building block. So without this, we can't actually, we can't be employed into this industry. We can't even work in the in the industry, because there are a lot of things that we need to learn, but with the help of what we've already achieved, what we've already learned in the four walls of the classroom, so we can easily adapt to what the direction that the industry want us to go. So part of what we did in class then, thermodynamics, but in LNG operation, thermodynamics is actually the heart of the business, because it is telling it is the course that shows us how refrigeration is processed, how refrigeration is possible, and the production of LNG. We talked about the fluid mechanics, so which the application in the LNG operation has to deal with the flow through pipe, pumps, compressors, different machine that we different equipment that we use in the industry still obeys all this fluid mechanics law. So we also talked about the heat transfer. So the heat transfer, in fact, that's another key important thing. When it comes to LNG operation, we have the main cryogenic heat exchanger, that is MCHE. So it is the heart of the business, and it is purely an heat exchanger. We have several heat exchangers that we still talk about in the course of this lecture, but one of the major one is the MCHE, main cryogenic heat exchanger. So we talked about the process control in the class. So process control, then we talked about instrumentation, metrology, all of those things comes together to play a good role understanding the DCS operation. Statistics, which has to do with process monitoring. How can you monitor your process? Something is going out of way. What are your response? So what are your prediction? Optimization, which has to do with production efficiency. So according to our topic tonight, we are looking at process optimization and operational excellence. So at any point in time, we have this topic, process optimization. Process optimization, this process optimization, that it's not something that bogus or something that is totally strange. It's all about achieving maximum output with minimum waste while maintaining safety, quality, and reliability. I can also remember in one of our courses then, we have and this course, lean manufacturing, agile manufacturing, just in time. So if you look at all the principles together, they are also in one way or the other talking about how can we optimize our process, how can we eliminate waste. In one of the topic too, by Dr. Kolawole, so we talked about productivity. I still remember, I may not define it verbatim, but part of the definition is producing more and more using less and less raw material. Please pardon me, sir, if I did not quote it correctly as you have taught, but I know that in summary, and that is what he's talking about, or producing more without adding additional input to the system, or having an increased production with a lower additional input. So in the long run, the process optimization is looking at how can we increase our production? How can we improve our equipment performance, reduce energy consumption, reduce downtime, and improve profitability. And the other phase that I will also be discussing tonight, that is the operational excellence. Operational excellence is the ability of an organization to consistently perform safely and efficiently reliable. Yes, you've optimized your process, you've done a lot of tweaks to make it work faster, better, more robust, but is it at the cost of safety? Is it that you are now jeopardizing your safety at the expense of your production? Is it that the reliability of your equipment now fall lower? So are you operating within that operating envelope, within the safe limits, just like we have it in the strength of material factor of safety? So we know that yes, our machine, our equipment can work for better and bigger, but we have just decided not to run it that way, just to make sure that we are working within that safe limit, that reliable limit, that we can say that, oh, our machine can continue to run continuously without breaking down. So the operational excellence is looking at the safety excellence, the process reliability, people development, continuous improvement, and technology innovation. So let me take you down to take you through a small journey of what I do in the process value chain. So like we have it in the screen, on the screen rather, the LNG process value chain. The first thing that I would like to explain to us is the natural gas, because without natural gas, we can't even be discussing LNG. So on the screen, we have some short definition of what we can get from natural gas. So natural gas is a gas that is being stored several kilometers down the earth crust or under the sea. It can be found as associated gas or non-associated gas. So in the long run, we have a natural gas. So what are we looking at in this discussion? So we'll be looking at LNG, which is the liquefied natural gas. It contains mainly methane, which is cooled to about 162 negative 162 degrees Celsius to convert it to liquid. So converting it to liquid, it helps to save volume and ease out our transportation. So instead of sending gas all through, so you can just pack it. Just I want us to like imagine something. We have a full cargo of ship. So instead of us putting a loading it with gas, so we now have to like cool it and liquefy it. So by cooling and liquefy it, we sending one cargo means we are sending 600 cargo from the for our buyers or for our clients. So the next one is LPG. That is the liquefied petroleum gas, which is also a mixture of propane, butane. It can also contain some compressed gas, which are both chilled or compressed into liquid form. So when it comes to about the space ratio, like we have 600 to 1 in the LPG, we can have about 250 to 1. So and it's commonly used for cooking, eating, and fuel application. So we also have what we call condensate, which is a light liquid hydrocarbon that is condensed from natural gas at a temperature at a temperature decrease during the production and processing, we have the natural gas liquid, which is an hydrocarbon separated from natural gas, including ethane, propane, and butane. So the picture you have on the right-hand side is just trying to like explain what are the constituents of each of these products that I have made mention. But in the long run, be it you want to have LNG, LPG, condensate, or natural gas liquid, we want to make sure that we kick out the 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 impurities, which are waters, CO2, hydrogen sulfide, mercury, nitrogen, and carbon monoxide, as some gas may have it. So looking at the LNG value chain, everything starts from exploration. So from exploration, and that is where people call the oil well. So from there, it goes to the production platform. Production platform is also called the OGGS, which is the offshore gas gas gathering system. So what they do there is to collect um, collect crude from several wells, or collect gas from several wells, and increase the temperature or decreases as the needs may demand. We also have the transport system, which has to do with the piping to the midstream. That is the liquefaction of the gas that they have sent, which is now the liquefaction of LNG. So from there, what are we going to do? Then after we've gotten our LNG or LPG or condensate, we are going to transport it to the location at which it is needed, where we have our buyer. So from there, we regasify it. Regasification means turning that hydrocarbon liquid into gas, back to how it was before, but in a purer state. Then we send it to a different consumer. So from there, we have other things that goes in line, the shipping, the marketing, and the selling, the marketing and the sales part. So and that is not the scope that we want to cover today. So anytime we are talking about LNG. So what is really happening behind the scene? So what is happening is that we are receiving gas from the OGGS, like I said. So we let down the pressure to knock out some liquid. Sorry, I'll be using some terms. So that's why I've taken my time to like explain the condensate, the natural gas, the NGL. Please pardon me for using those terms to make it easier. So from there, we go to what we have, what we call the gas pretreatment. What are we doing in the pretreatment zone? We are just doing three major operations, which is take out the acid gas, and take out water, which is dehydration, and take out mercury, because mercury attacks aluminum, forming amalgam, that's which is the main heart of the liquefaction process. So we also have the liquefaction itself. From the liquefaction, what we are going to get is the LNG, number one, then followed by the natural gas liquid. So from there, we take it to the storage and load it to the ship, and then the ship sail. So once we are discussing this topic, it looks simple, but in reality, this system don't exist on its own. It also have other utilities that makes this work. So that is where we talked about the air, the nitrogen, because you have to be producing nitrogen, liquid nitrogen. So we also have the production of power using the gas turbine. We also have heating process. We have fuel gas to power the gas turbine. We have fractionation. we have how we are going to like dispose our liquid or dispose anything that may cause hazard. Yes, when it comes to LNG in the first place, it is before it is a waste product. Now it is now being reconverted into a useful product. So we don't want to flare at the production site, but in the real sense, we can't actually operate without flaring. So what are we going to do? Just have to make sure that we lower and minimize the flare, because it has a devastating and environmental effect. So we also have the fire protection system. So all of this system, we can use different methods to achieve it. It's either we can use the cascade process, C3MR, which is the major thing that the industry is using. We can use DMR, or we can use MR. So D means the dual mixed refrigerant, S means the single mixed refrigerant, or we can use nitrogen expander, as the case may be. So improper, what are we doing again? Because some people will still be amazed. We still ask the question, will you have only showed us diagram? Okay, how is this thing achieved? So just like I've explained earlier, we take in our gas from the production site through the pipeline after liquid have been knocked out. So, but we are still going to knock out the liquid. The liquid are called the condensates. So from there, we remove the acidic gas, which can be CO2. We don't just remove it and dispose it to the atmosphere. We make sure that we incinerate it, make it safer for environment. So after then, we have to cool it a little bit. Cooling it a little bit cause what we cause condensation. And for that condensation, that means the water and the gas will now have to separate. What are we going to do? If you can see my mouse moving, please confirm you can see my cursor moving so that I can just use the pointer to point to that direction. Dotun, please confirm you can see my cursor moving.
Can you move it again? I'm trying
Okay.
to.
Okay.
It's mine that I'm seeing.
Yes,
Sorry.
it's moving.
Okay, it's
You
white.
are on water
Yeah,
now.
it's a white one, white cursor, right?
Okay, yes, white
Yes.
cruiser.
Yeah,
Okay, yeah.
I see.
So from there we knock out the water, then we take it to through the dehydration bed. So the dehydration bed, they are just packs of mole sieve knocking out water. So from the water that we are going to knock out at a particular point in time, and those mole sieve will be saturated with water molecules. So what are we going to do to them? We are going to regenerate it. Regenerating means eating that bed to knock out water again. So why we are doing that, we are also compressing the gas back into the system to process it so that nothing wastes from our raw material, because at any point in time we are flaring, we are wasting gas, because those gas are not actually free. Yes, it comes as a result of waste material, but now it's no more a waste material, it is a product, and we have to make sure that we recover every bit of it and use it for production. So then we knock out the hydrogen through the process called the hydrogen remover. So sorry, we knock out mercury. So why are we taking out the mercury? Mercury attacks the MCHE. The MCHE, which is the main cryogenic heat exchanger, is the one that helps to really achieve that negative 162 degrees Celsius that we are looking at. So and it is made of aluminum tubes. If you allow mercury to go in, it's going to cause amalgam. And you can go on YouTube and check what is the reaction of mercury with aluminum. That's why at any point in time you want to travel and you have mercury in your luggage, they will not allow you to fly the airplane because most of the parts too are also made of aluminum, and you can affect the structural integrity because mercury mixing with aluminum is going to corrode that aluminum. So, and that is not allowed in the system. So what are we going to do? We are going to remove it. Then we further cool it through our heat exchanger. So from there, we pass it through this MCHE, which cool it to negative 162 degrees Celsius. Then we store it in the LNG storage tank, which is a special tank designed to keep that cryogenic temperature. So no matter how we try, some gas is still going to boil off. What I mean by boil off is heat up. So once those gas heat up, we are not going to allow it to waste. Rather, we compress those gas. So we have two options. It's either we send it to our turbine to run as a fuel gas, or we reject it back to the system. But in most of the cases, it's advisable to take it to the fuel gas, to the turbine, because it is a cleaner source of fuel. So from the LNG storage, then we load it into our ship. So this is what we call the loading arm. But all of this cooling process is not just possible with what I've explained. Rather, we have two things that is really doing that cooling process for us. We have what we call the C3 loop and the mixed refrigerants. In the drawing here, you will see MR. What I mean by C3, please pardon me, C3 means propane, just like we have it in our organic chemistry. C1, which is methane, that is CH4. So just like the alkane group, which each family differ by C, and I think CHN plus 2. So just keep on doing that loop, CNH2N plus 2. So sorry to be quoting that. I know that most people here are professionals. So, but pardon me, I have my prof and I have many of my ogas here. So please pardon me if I'm doing too much. So then the MR loop, they are mixed refrigerants, like I said. So what does it contain? It contains the C1, which is the methane. It contains the C2, which is ethane. It contains propane, which is C3, and also contain nitrogen. All of these four constituent elements are mixed in the right proportion, just like we have in one of the thermodynamic class. We have something called dual refrigeration, like a multi-stage refrigeration. So you can't achieve a particular temperature at once. So what are you now going to do? You are cooling the condenser. The condenser of the first stage is connected to the evaporator. Okay, sorry, the evaporator of the first stage is connected to the condenser of the second stage. So that the evaporator of the second stage now give you more cooling. That is actually what we are doing in this system. So we have the first stage cooling, which is the C3MR. To understand that, you can go through the LTAP curve, propane curve, but I do not want to bother us with all of those technical jargons. The agenda for tonight is totally different, but I just need to like explain what is happening behind the scene. So after the gas have been pre-cooled, we have what we call the scrub column. Let me go back. This blue vessel is what we call the scrub column. It is the one that we it is the one that will now allow us to separate those natural gas, that will help us to separate the heavy from the light. Okay, and the scrub column is actually missing in this diagram, but we have something called a scrub column. The scrub column is in between these three exchangers. You can see 1, 2, 3, 4, 5, 6. So they are just exchangers. They are C3 exchangers, which is propane exchangers. So when gas is being pre-cooled to about negative, let's say negative 42, the gas and the liquid will now separate, because with all our acid gas remover, we still have some heavies. Remember, the constituent of natural gas, it is not methane alone. We also have other constituent elements with it. So it is at this stage, those elements get separated, and we call them the natural gas liquid. It should be NGL, not NLG. Please pardon me. It is NGL, natural gas liquid. So at this stage, we are performing a recovery process. The recovery process is now, we want to stabilize those natural gas liquid. If I can quickly rush to the first, to some of my previous slide, and the NGL, if you can see my screen, we have ethane, propane, butane. So we now want to separate these three elements. Sometimes it can be 4, sometimes it can be 5, depending on the constituent of your gas that you are processing. So that is what we are doing at this point. So how are we going to do that? It's just the same thing, like how it is the same way like the fractional distillation, but in general we call it fractionation, which is we are now heating those natural gas liquid into their respective temperature to uh, to to collect a purer form of those gases. So that is what is happening in every of these column. So we have the ethanizer. You can see that at the bottom we have um, 120 degrees Celsius, and at the top it can be like -5 or 5 degree, but in most of the cases we usually have it around a sub-zero temperature, like -5, -4. So just imagine you are boiling here, and at this point you are freezing in this same colon. So you could have imagined the kind of thermal stress that we've subjected those colon to. So we have the propanizer, which also have almost the same profile, but a little bit different. We have it being heated around 130 degrees Celsius. Then the top of it is 45 degrees Celsius, then the butanizer. So what varies around from this colon, it is the pressure at which they are operating. So to understand this, you will need to understand what we mean by enthalpy, and phase diagram. So that will give you a proper insight of what we are talking about. So to those people that have said that school is a scam, I want to tell you that school is not a scam, because to understand this, you need to understand what you have been taught at the fundamental level. So as a DCS operator, what are you looking at? You are just looking at parameters. But in most of the cases, for you to be a DCS operator, you should also have field experience. You should know how that particular thing that you are controlling, how does it looks like in real life. So you won't just get into the system and you will now start operating the DCS. So before you can be a DCS operator or panel operator at the control room, you must have understand and walk through your line. What I mean by your line is the pipe, the columns. Understand where they are, understand how they behave, understand which valve you are operating, understand the implication of what you are doing. So it is all of those knowledge you will bring on board to make sure that you can be a competent DCS operator or panel operator. So what are you looking at? You are just looking at all of these values. Those values are real. They are not just sitting on the screen for you to play around with. It is actually the kind of value that determines will your equipment survive? Are you running within the operating envelope? Are you causing your equipment harm? Are you running out of control, or you are operating within the tolerable limits? So my role in this value chain, sorry, I want to check on my time to make sure that I'm still within, I'm still within limits. So my role in this value chain is to make sure that that's why I'm carrying out my operation, I'm monitoring the plant's condition, I'm controlling the process variable, I'm responding to alarm, troubleshooting abnormalities, maintaining product quality, supporting safe operation. And how do I achieve this? Um, um, I I usually achieve this by this fundamental training that I've also taken in addition to what the school have taught me. So that is the DCS. I have to understand my P&ID. That is process understanding my process, understanding the line, and that is process identification diagram. So understanding my SOP. SOP means standard operating procedure. Understanding the PTW, that is the permit to work system, the alarm system, trending, which is process historian, having that engineering knowledge which I've had in the school, how to communicate, how to work with the team. And then at the end of everything, I must make sure that I'm achieving all of this within the with safety as a culture, with safety in mind. So that takes me to the next one, which is leadership beyond job title. So when I first start to when I resume work as a panel operator, because like I said before, you can be a panel operator, you have to understand what is happening on the field. So you are now facing a life plant, and this life plant that we're talking about, if any small thing happen, they say that, oh, train trip, and this train that trip, what can it cause? They will tell you, oh, we've lost 300, 500, 1,000 metric tons of um, of LNG. Then you now want to try to like Google check, okay, what is 1 metric ton? Or let me say 1 kiloton. How much is it? You'll be seeing some kind of big value, like 500 on US thousand. So you will now do that calculation. So I've cost the complaint 1,000 metric tons. You calculate it, you calculate your salary, you calculate everything. Say that, oh, even if they sell my family, I don't think I can actually get this amount of money to pay them back for the losses. So I'm just citing that as an example, but in the real sense, that is what happens. What if the worst happen, which is you have an incident and it involves company reputation, which you cannot buy back with money? So in that little position, that I'm holding. So I can see that, oh, the life plant is now in my hand. What do I do with it? I must make sure that I run it safely, making sure that nothing happens to it. Uh, um, 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 I mean, nothing on one. How do I want to put it? Making sure that something that is not expected happen, making sure that I operate within limits. So the leadership is not just about the position, it's about the action. Every click I click, every move I I I take, the way I'm responding. So uh, I am actually responding to a multi-billion-dollar asset. So I have to play very safe. I have to make sure that the way I'm executing my tasks, it's not just by thinking, it's not just by irrational thinking rather. So I'm now taking ownership. I'm now influencing positively. I'm mentoring others because people will come to you. People will ask you question, why are you doing this? Every action you take, you are the owner of that action. Um, because the action you take can be traced back to you, and you can be held liable to your action. I'm now solving problem. At the end of everything, I'm looking at continuous improvement. Oh, what are we not doing right? How can I improve? So, and I'm also learning on the job, which is continuous learning. So I would like to say every engineer can become a leader. And in fact, every engineer is a leader. At every point in time, I want to go for LMRE. LMRE means last risk assessment when it comes to permit system. So you will see a lot of professionals gather in their number, in their 20s, 30. These people, they have years of qualification and they are just waiting for you to approve their permits before they can go ahead with their work. So in one way or the other, you are already leading. The multi-billion assets have been committed into your hand. So what are you now doing with it? So will you allow it to like get spoiled in your hand? So as a student, what are we looking at? We are looking at how can we build our technical skills? Technical skills, in the case of engineering fundamental, how are we able to understand what we have taught in what we have been taught in class? Because it is still that same thing that we apply to the field. You are looking around the process simulation, data analysis, digital literacy, the AI skill, everything, it is all needed. But while you are having that kind of technical skill, also have the soft skill. One thing that I've always noticed for engineering students, we are always full of technical skill. The soft skill, which has to do with communication, leadership, critical thinking, teamwork, adaptability, and emotional intelligence, we are not always very keen about them. And most of the people in other departments usually use this against us. But I want to challenge every engineering professional that the soft skill, they are also very more important as well as your technical skills that you've acquired. So from my experience, what I've been able to learn is never stop learning. Understand the process, not just the equipment. Once you understand the process, you understand, oh, what goes into what goes into this pipe, what is expected to happen if I take this decision, not just the equipment. Understanding the equipment, you have been taught in the class, oh, what is compressor? Compressor compresses gas or fluid. Okay, compressor compresses liquid. What is pump? Pump pumps liquid. Sorry, compressor compresses gas. Pump pump liquid. You've had that understanding about the equipment. When you are asked what is turbine, you can perfectly define turbine, explain how it works. But it is not just that equipment. Understand the process. This particular process that I'm doing, what is the implication? If anything goes wrong, what is likely to go wrong? If I want to correct it, what are the corrective action that I have to take to normalize normalize that process? So another thing is safety. Safety, it is non-negotiable. At any point in time, you are dealing with business, dealing with investment, and you should always make sure that the safety of your people, the safety of your money, the safety of what you bring in, it is always guaranteed, and it should not be negotiated with anything. Understand and build relationship. So it is not just the technical skill. Build relationship within your field and outside your field. Seek excellence daily. We have this book, Atomic Habits. It does not necessarily mean that you have to do something big. Something little, something little by little every day. Just add something incremental. Maybe as low as 1.01. So that's 0.01 is going to make a difference in the long run. Converting problems into opportunity. Be a salesman. You are the one that will sell yourself. So you are not expecting anyone to be your salesman. You have to learn how to speak and to project yourself positively. Also learn finance. Some people in this organization, in this industry, you will see that they are getting a lot of cash flow, but in the long run, you notice that they are struggling financially, and you have to ask yourself, why are these people still struggling financially? It's because they have failed to understand the rudiments that they're supposed to understand, which is understanding finance, understand how treasury bill work, understand how stock markets work, understand how tax work, understand the kind of policy that have been recently made, so that you will use all of those things to your advantage to make a informed decision. So for the listeners, I will like to challenge us, especially the students. Learn beyond the curriculum. It is not just ordinary what you are being taught in school. Expand that knowledge. Read about different articles. Read about what is happening. The Strait of Hormuz. How is it affecting us as a country? What are we doing? Um, how can we manage the situation to make sure that we are also being profitable? So also become comfortable with data. You'll be seeing a lot of data. So your data analysis skills should be top notch. You should also understand business, not just engineering. Have this kind of mindset that for your organization to get you on board, they are all looking for profit. So understand how your action is bringing values to them. Understand how the business work, so that you can make informed decision. Build communication skill. This one, I'm also building it. Myself, I used to stammer, but over time, I've tried to manage it and develop it little by little. It is not at once to get it right. Over time, you'll become comfortable with it when you are delivering your speech, you'll be so comfortable. And when you are selling yourself as a salesman, you are so fluent and eloquent. Yes, it is not a one-day journey. You get there gradually and develop leadership skill early. This one really catch my attention, developing leadership early. While in school, we we always push the responsibility to the class rep. Oh, class rep, you are the one. Oh, please go and represent us. Please, don't do that again. Take take that um take take that responsibility of being a leader early enough, because it's going to like help you in your career advancement. So when it comes to leadership, you have to first lead yourself. Yoruba people, we we say, please pardon me to like quote this adage. What ẹni tó bá fẹ́ dáṣọ fún ni títọrùn ẹ̀ ní àkọ́kọ́ wò, which means if I want to clothe you, you have to look at me and see, what am I putting on? Am I looking gorgeous? Am I looking well dressed before I can say that I can provide you this clothing or this shelter? So when you lead yourself properly, then you will now extend that leadership to your subordinates. You lead your subordinates. While in business, while at Lagos Business School, one of those things that they also taught us is how to lead your superior. It's not just yourself and your subordinate that you have to lead. You also need to understand how to lead your superior. How do you lead your superior? You give them you present the problem and the solution. Some people will only go to your superior and present the problem. We are having this. So we are having this particular problem. No, you present that that problem with solution. Your superior will be happy with you and say, okay, good. So your superior will just have to take few decisions, and you've achieved what you are looking out for. So to round up, I would like to read through some of this code that I've written. Engineering is not about passing exam only. It's about making decisions that keeps people safe, keep plant running, and create value every second. And the future of industry will reward engineers who can combine technical expertise, operational awareness, digital skills, and leadership. Degrees and certificates will open door, but value creation keep those doors open. Operational excellence is not the absence of problem. It is the ability to recognize, analyze, and resolve them safely and effectively. The same mindset transforms challenges in life into opportunity for growth. So in conclusion, I would say that the classroom has provided the foundation of knowledge and introduced me to principles of engineering. The control room transformed that knowledge into practice and taught me the weight of my responsibility. The process optimization revealed the power of efficiency, while operational excellence instilled that discipline required for sustained performance. Together, this experience shaped an engineering graduate into an energy professional beyond the boundaries of industry. The lesson remains the same, whether managing a gas plant or navigating life challenges. Excellence is achieved by understanding the process, recognizing the deviation early, making informed decision. Excellence is not a destination, it is a continuous journey of learning, adaptation, and growth. Thank you. At this time, I will yield the floor to Dotun for questions, comments, or feedback. thank you very much. And thank you once again for the opportunity given to me to deliver tonight's lecture.
Excellent. Thank you so much, Engineer Afolabi. If it was a physical event, I would have asked everyone to give you a standing ovation because it was that good. We didn't even know like how much time had gone. You carried us through from start to finish. You took us to the classroom, you took us to the control room, you reminded us of things we have forgotten, and you gave us important and timeless life lessons. What a beautiful lecture. And nobody would have guessed that you had issues with speech before now because you delivered it so flawlessly. Thank you, thank you, thank you. If it's from UI, it is the best. And if it is from industrial and production engineering, it is the best raised to power, I don't know, raised to power what? Raised to power 10. All right, I'd like to welcome our chairperson to give his remarks on the lecture, and afterwards I would open the floor for questions. So please let's welcome again Engineer Bola Olowe FNSC.
Yes, thank you, Doctor. And I want to thank you, Afolabi, for a wonderful presentation, quite enlightening and quite eye-opening. And I'm sure the students amongst us will have gained quite a lot from you, the extent to which you have mastered your trade and how you are able to relate the classroom experience, classroom lecture to your control room, as it were. One thing that I want to also take away is that from this lecture is that leadership is not a position. It is not a title. It is action. It is example. And this Afolabi has demonstrated to us today by being able to show us the action and also give us the example. So I want to thank you so much. And also that every engineer is a leader. An engineer who has gone through the crucible of the university and eventually has emerged is a leader by all definition. So thank you so much. Thank you, everybody. I wish us a very rewarding experience, and then I yield to Dr. for the question and answer. Thank you.
Okay. Thank you so much, sir. You captured the key lessons very succinctly. Thank you. Shortly before I go into the question and answer, I already see a question in the chat box. I'd like to ask our other special guest if they would like to speak. Our mommy, Mrs. Adejoke. Funny enough, my mom's name is Adejoke. Mrs. Adejoke Akipelu, would you like to give a comment before we go on to the questions?
I don't know, and I don't have a question. I don't know much about engineering, but the delivery was well done. And I think that he has shown us that if we are interested in our job, we can always do our best on it. So I thank him for the delivery. So thank you.
Thank you, ma'am. All right. I will go on to the question that I saw in the chat earlier. Okay, this is like career advice is being sought. What entry routes can you suggest for an engineer who has no related industry experience and has left school for over 5 years? That is the first question.
Okay, do you want me to take it one after the other, or you want or we should compile it together?
Oh, for now, this is the only question. So you could answer
Okay.
this.
All right.
Yeah, first.
Okay, so for a person that do not have the engineering background and I've been out or the person have graduated for a while, right? Like 5 years.
Yes.
Okay, good. So the best route I would say is the person can take a professional courses. So taking a professional courses will help to realign that person, because on first thing, you do not have the engineering background. So which is a well, is it as a disadvantage? Well, if you know how to convert those um, those challenges to opportunity, it can also be to a greater advantage. So what are you going to do? You still need to blend yourself with the engineering practice. Take a professional course that realign you with what you want to do. So if you want to do like cyber security in engineering, you can take such course and look at how cybersecurity is applicable to the oil and gas sector or to energy sector. And then you find your way around it. Go for internship, be tested. Once you are being tested and people can recommend you, and your work will definitely speak for you. So once you have all of that in place, trust me, when people see your qualifications, see what you've done, see and your delivery, they won't even question you too much, because they know that, oh, they are speaking with professional. So that's what I can say. Back to you, Dotun.
Okay, thank you. I really agree with what you said, that they might be able to leverage their challenge, quote and unquote, as an opportunity, because the non-related industry experience definitely has some kind of wisdom or knowledge that can be transferred into the engineering space. Like you have many of the things you said today, I'm sure that even people that are not in the engineering space can find it useful. You talked about awareness of situation, problem identification, noticing deviations. Those things cut across board. They don't only apply within the control room, they apply even for basic life, human life, managing yourself. So wherever it is that the person has been, I believe that they can just identify what they have gotten, the value that they have gotten in whatever industry they have been in, it can be transferred into the engineering industry. So thank you for that. Henry says, I have an oil and gas tech startup. We speak to the pain points of equipment procurement and lease challenge in the sector. How can NLNG use our feature? Okay, so this person is selling his market in the comments, ironvaultenergy.com. Then there's another person that says, please, how do you handle field equipment failure during production?
Okay, so I'll go for the first question. If you notice in my presentation, all the pictures I use, especially the one that has to do with the complaint, I have to even put a reference to them. So I am here as an individual. I do not speak for my company. So if you need insights on that, you can contact the external relations. You can contact other uh, um, other aspects. I mean, other office within the company. So I am here to give the lecture about how things look like. I do not speak for my company. So that would be my response to that. I'm so sorry, but that is the reality. Um, I part of the communication involve the strict measures, and I do not take anything that has to the complaint personal. The complaint has a proper body that focus on that. I'll go to the next question. The next question is talking about the equipment failure during startup, right?
Yes, during production.
Okay, during production. So we have a system, we call it M+2. It is also like a reliability system. In reliability, we call it redundancy. So if an equipment fail, especially maybe the pumps, most of the pumps are, are usually M+1. And for critical pumps, maybe auxiliary pumps for a bigger machine. Take, for example, you have a turbine. I not remember to say it during my lecture. Those time they usually taught us what is turbine, how does it looks like, but they are just like pictures why we are doing it. But I've seen it in real life. I've seen the internal parts. I've seen how it works, and I can speak from experience that this this critical equipment, they have auxiliary systems that helps them to run. So those auxiliary systems, they are usually in like 2 or 3s, especially their pump. You have a siloy pump, you have I don't want to go into too details, but in a nutshell, we have a redundancy system that works, but it is not every one of them has a redundancy system. The main cryogenic heat exchanger, you can't afford to get to have 2 within the process. So that system must work. So how do we operate that? We have to make sure that we operate within the safe limits. We call it operating envelope. So once you are operating within that, and then you also have what we call layer of LOPA, that is layer of protection. So should in case you did not catch up with an alarm or with a process early, so you have SIL or SIF, that is safety instrumental function, to take it out for you. We call them safeguarding systems. So those safeguarding systems will come like a police and stop you from doing that work. So and in the worst case scenario, if you do not have that happening, you have what we call the mechanical safety function, which are the relief valves, which can be any kind of other thing to stop that equipment from you wrecking them. So as a operator or as a DCS, you must catch up those things early before those things fails. But unfortunately, they fail. If they fail, we have redundancy for them. Thank you. Back to you.
Thank you. Thank you so much for your bright and intelligent answers. I'm sure everybody has learned more than a thing or two tonight. So if you have any closing remarks that you would like to share at this point, we are open to hear what you have to say.
Okay, and Dr. Is it for me or for Prof?
No, for you, for you. Yeah, just your
Okay, okay. All right. I will still continue again with my vote of thanks. I remember that time while I was still schooling. So we have this speaker then, engineer Adebayo Otokiti. He discussed about the acts of problem solving, applicable principle for a successful career. Then I'm still around the corridor, have not gotten fully onboarded with the system. So I was listening to him just like every other person listening to me tonight. So, and when I eventually get there, I truly see that, oh, what he was saying the other time, being a senior engineer, is still the same thing that is happening right now. It is all about problem solving. If problem do not exist, they won't even call you in the first place. So problem exists. The system still need to be optimized. We want a process optimization. We want operational excellence, and we need continuity. So that is why we've get you, me, everyone on board to work with us. So while doing this, you must make sure that your leadership skill, because that's that technical skill, that technical skill that you said you've had, everyone within your team, they are equally an engineer. So how can you thrive in that competing role? You have to make sure that your leadership skill, your soft skill are really of top notch. And with that, I can tell you that if you continue doing that, success is awaiting you. So to wrap it up, I will say a very big thank you to Professor Oladokun for giving me this great opportunity to speak with with these wonderful people. I'm looking at the numbers at a particular point in time. I was saying 60 something. I said, oh, wow, this is such a great number. Thank you very much. Thank you for the opportunity. Thank you thank you, my friend, my colleagues that you've also joined. I really appreciate your support. Thank you, everyone. Back to you, Dotun.
Thank you, thank you, thank you. I like that you mentioned your colleagues. I'm surprised I didn't see them in the chats. I would have thought that they would have been championing your, but I know I saw Tosin earlier. So if you are in Afolabi's set, please let me see you in the chat. Let me see you celebrate. Let me see you celebrate your set mates, the first of your set to deliver such a powerful lecture. And he has set a wonderful precedent. I look forward to seeing others of you as well. As we have seen, Professor Oladokun has been sharing his screen. We we have the notice of retirement of our dearest Professor Oleye coming up in September. And these are the dates and information that you need to know. There's also the account details that were shared previously. Please contribute towards honoring the legend himself, who has served selflessly, wholly, and with so much kindness and generosity for 45 years. Yeah, it would be wonderful to give him a befitting valedictory celebration. So bear in mind and make the decision to be a part of making it a great one. Thank you. Next month, we'll be here. Coincidentally, we'll be talking about leadership and legacy. I think that's a very nice continuation based on everything that Engineer Afolabi mentioned today. Mentorship, yeah, engineering growth, leadership, and legacy. So that would be an insightful and knowledgeable conversation, as it always is. I am Dotun Kasim, and I am very happy that I got to do this with you all on this beautiful Democracy Day. I would like to welcome Engineer Dr. Omotunde Muyiwa to give the vote of thanks. I know I saw them. I saw him in the chat earlier. So where is he now? Maybe network, because like a few minutes ago he was in. I would just like to call Dr. Kolawole in that case. Dr. Kolawole, sir, can you please do the vote of thanks?
Okay, thank you for giving me this opportunity. Well, we cannot thank everybody enough tonight. I want to appreciate all our guests who have found it, who have spared their precious time to be here tonight. We thank our chairman, Engineer Olowe. Thank you, sir. We also appreciate our Deputy Registrar, the PR of the university for now, grandma and the mommy of our students. Thank you, ma, for coming, not only be here, but you are in time as we have had. Thank you for your contribution to the department and university at large. In most university occasions, we see you here and there, anchoring activities for the university so that we can be where it's supposed to be. Thank you, ma. We thank the guest speaker. Well, he has spoken a lot. He has really moved from classroom to the control room from what we have had, from the theoretical knowledge that he has gained in the school, not only gaining the theory now, but putting everything into practice. I think I demonstrated really the topic he has shared with us from what he is doing and from the way he started the lecture, thermodynamics, fluid mechanics, and where the practical aspect of becomes the reality. Thank you for this lecture. We are very grateful. And we appreciate everyone who is here tonight, students, alumni, every one of us who have been supporting the department and the activity we have been doing. We want to appreciate everyone for making out time to be here again tonight. And as we have been saying, we're almost 4 years in the business, and God has been helping us. It's not only the department alone, but definitely our alumni who have given themselves up to share their lectures, share their time, and even their resources in order to ensure that this program continues. So we want to thank everybody. The moderator, your beautiful voice is there again tonight. Thank you. And everyone, we want to thank the head of department too, who has been anchoring this program, and other people who work underneath. Engineer Padare, the engagement team, Dr. Adeyeye, many of us under the background that ensure that this program continues. I want to thank everybody and say have a beautiful night rest from Nigeria, afternoon somewhere else, and deep nights in some places. I want to say thank you and thank you. We look forward to see you again by God's grace, Friday, July 10th. We can have another refreshing time together. Thank you. God bless.
Thank you, sir. Good night, everyone. Bye.
Yeah. Bye-bye.
Bye. Thank you.